Hi everyone, welcome to Tech Simplified by Rajdeep, where we simplify backend engineering one concept at a time. Today, we are kicking off the high level design, a practical approach series. And in this very first video, we'll tackle something very fundamental. So, let's proceed. So, it's a new beginning for us, it's a new channel, it's a new playlist, and hope that with this playlist I'll be able to provide some value and add some knowledge regarding high level system design for you. So let's start. So the first section is the fundamentals. And in this very first episode, we'll tackle two very basic questions. What is high level design and why does it even matter? And this will be from very from two perspective, that is from projects or even from interview perspective. Okay, so what is the problem, right? The problem that I have seen across in my career is high level design is not only about drawing few boxes, and most people think that it's about connecting few boxes, drawing drawing flows like for example, you see this flow where the front end and the back end and the DB is connected. Drawing simple flows will result in a good high level design, but that's not true. That's not how systems are actually designed at scale. Not at places like top engineering teams and or top tier companies. Okay, so today we'll break it down properly. So high level design or HLD breaks it down into few pointers, right? The first pointer or the question that high level design answers is what components are involved in a system or for building a system. Okay. Second, it tells us how do these components even communicate. Okay. First is what components, second is how do they communicate. Third is how do we handle scale or what do we do when we have too many requests for our system. Let's say we are building a social media website, and when we start off we have, let's say, 5 or 10 or 100 users. Suddenly our app becomes very popular and we see traffics of around 10,000, 20,000, 50,000, or 100,000 users. So how do we handle this load? The next point that high level design helps us to answer is how do we handle failures or errors. Okay, so what do we do and how do we report, and what actions does our system take, be it in an automated or a manual way, when any failures occur. And the final point that according to me the high level system design thinking answers is what do we do for slowness in the system, or when we observe latency in the system, right? So we are not thinking at the class level details, like what classes do we define for a particular functionality or a business process. We are not thinking about that. What we are thinking about is what components we will use. Are we using APIs? Are we building APIs to expose our functionality? Are we using queues or message queues? Are we using databases? What kind of databases we use? Are we using SQL or NoSQL databases? What suits our use case, right? How are we managing the traffic and the load? How are we deploying our changes? Okay, how are we monitoring our servers so that we can be responsive and we can handle failures and errors gracefully. So all these points are covered in high level design of a system. Okay, so this is the direction in which we should think whenever we talk about high level design of a system. So a golden rule that I follow is, for a high level design, I see that how things talk to each other and how to keep them talking even when things go wrong. Correct? Even when the system becomes faulty, how the system handles the failure, that is called fault tolerance. So that is what. So let us understand all these points with a practical example, right? So in this example, let's say we have a team called Rockstars, okay, and they get a project to build a notification service for an e-commerce website, okay. So the team is very excited and they start building the notification service. So the architect in the team, okay, this is our architect. The architect starts designing the system on a high level, and then he provides us this diagram. It's a very simple diagram. So we see some is, so the notification service has some incoming requests to send out notifications. Let's say it wants to send out 1 million notifications, okay. So we have a very basic component. Let's say we put in an API gateway, okay. This acts as a gatekeeper for our notification API. The API gateway receives the request and forwards it to our rate limiter, okay. So the rate limiter prevents our notification API from unauthorized access or DOS attacks and stuff like that. We'll learn about all these things as we progress in this course. So for now, just stay with me, and the notification requests come through the API gateway. They land into our rate limiter, and the rate limiter forwards it's to something called message queues. Okay. So let's say we have few message queues here that we have denoted as Kafka queues, and we'll learn about each of these components slowly as we move forward. So once the notifications are placed on these messages, we have multiple workers or multiple machines that are subscribed to these queues, right? So they have a subscription on these queues. Once a message is placed here, let's say this is a message, this is a message, this is a message, and this is a message. All these workers get a notification from here, okay, as they are subscribed. So once these workers receive the notification, so every worker has a single responsibility. Worker 1 will only send out emails, worker 2 will only send out SMS, worker 3 will only send out push notifications. So once they receive the messages from the queues, they start acting and they start sending out their respective notifications. The worker, all the workers are connected to a Postgres database for storing the logs of the transaction, and also they are connected to a Prometheus or Grafana server service, and they are flushing their events into this service, and this service help in our monitoring that which were, if any error occurred or in any of the workers or not. So this is a very basic example that our architect has prepared as a high level design for the notification service. So without going into the details, what I want you to understand now is the way, the thought process that our architect put in here, right? He selected an API gateway, he selected a rate limiter, then he selected a then he selected message queues, which will have the messages placed on these queues, and through which he selected a multi-worker strategy. Okay, each worker serving us a separated way of sending the messages, and then all these workers are connected to a database or a Postgres database to store the logs, and all these workers are all also connected to a Grafana service for event capturing or monitoring. So this thought process or this uh, flow, that what components will be used and how each of these components talk to each other, what they send to to the other service or component and what they receive. This is what high level design is. Okay. Now we move on to the next point that we have, what actually matters. Like when designing all these systems in the industries, in real life systems, what factors are mainly the ones that matters, right? So the first one is latency. Like we ask a very basic question: is the user waiting too long? What are we doing to resolve that, right? Second is availability. Is our system always available? Let's say for an e-commerce website, is our system always, can the user log into the system always? Okay. Third is the scaling strategy. Let's say our business is growing and we need to scale to multiple regions, multiple countries. Okay, we need to serve, let's say, 1 million, 2 million, 10 million, 10 million, 50 million concurrent users at a time. How that is being handled. And the fourth one is observability. That boils down to the fact that how we can debug what's failing in production, right? So our HLD must answer these questions before any code is written. And that is the work of an architect to have a proper high level design ready, so that creates a thought process amongst the developer team, and that thought process slowly converts into low level design, component by component, right? So some real life observations from an architect perspective is, a very dangerous thing that happens is people just copy other systems as is, right? We are copying, let's say, let's do it the way Netflix does, or do it the way Uber does. We have to understand that high level design is always context driven. Okay, there is no one size fits all solution when we are talking about high level design. That's one thing. Second is, while doing a high level design, let's say in our project or even in interviews, we always have to design for scale. Designing a system for 1000 users is entirely different from designing a system for 1 million users. So we have to understand this, and accordingly we have to make a decision. Okay, and we have to always prevent over engineering of our solutions. That is what I've realized from my experience. Next point, high level designs also depend a lot on the product type, right? So let's say a SaaS product will be very different from a real time trading system product, right? Which uses high frequency transactions and all. So product type also defines the type of high level design, the type of architecture that we will use. And the final point that I see a lot is, a good high level design uh, mostly takes care of these three pointers. It adapts to our use case, right? It adapts to the constraints that we have, right? And it always adaptable to the team's skill sets. So we are not married to one language or one tech stack or one framework. A good high level design always adapts to the team's skill sets, right? So this was the main things that I wanted to talk to you about high level design, and this was the first video in the series. So do let me know your comments, feedback, so that I can improve further. And next, what I'm planning in this series is, uh, we will start with the design of a real world system, and we'll see how we can apply this thought process and the concepts that we discussed here into our real world system. So just to sum up quickly, high level design is our blueprint always. So it's how the system will look like, what components will be there, how they will talk to each other, and it lives before the code, right? Code comes later, this comes first. And it should always answer our architectural questions and decisions. Okay, and most importantly, it considers real world constraints. So that was it for this video. Thank you a lot for your time, and I'll see you in the next video.